Hi everyone. Today we're going to go over what I call my last minute Lucy log review. So preparing in order to prepare for our exam next week. So getting started, we have the equation 4 to the 4x equals 64. And I do notice that I would be able to get my bases the same. I can either set them equal to 4 or I can set them equal to 2. So 4, would say 4 to the 4x is equal to 64. Another way of writing that is 4 cubed. So my bases are the same. I can say 4x is equal to 3. X is equal to 3/4. Excuse me. And that would be my answer. Another way of doing that is to actually get the bases set equal to 2. So just giving you some options, I can rewrite 4 as 2 squared. And I have a 4x there, and 64 can be written as 2 to the 6th power. And in doing that, my bases are the same again, and I have 8x is equal to 6, so x is equal to 6 over 8, which reduces by 2 to 3/4. Okay, so options for you. For this problem right here, we are not able to get the bases the same. So there are a couple ways of doing this. If you didn't have a calculator, this problem could be done by taking this exponent part out of the exponent place. And in order to do that, we're taking the inverse, which is a log. And so we're going to have 3x plus 1 log 2 is equal to log 9. We can say 3x plus 1 is equal to, and I'm going to divide out the log of 2, log base 10 of 2. So we're going to have log base 10 of 9 divided by log base 10 of 2. This being a quantity, I'm going to subtract 1. So I have now 3x equals log base 10 of 9 divided by log base 10 of 2. Subtract 1. And then lastly, I would divide by 3. And in doing that, I would get x equals this quantity, log 9 divided by log 2, subtract 1, and that's all divided by 3. So this would completely work. There are other ways of doing this, and one other way that you could do this, just for fun, if you wanted to experiment, is just to distribute with the 3x, meaning you'd have 3x log 2 plus log 2 is equal to log of 9. You'd have 3x log 2 is equal to log of 9 minus log of 2, and that's subtraction. So that would actually be log of 9 minus log 2, so log 9 halves. Then I would divide by log 2. So there's other ways to do this. It's just how you want to do that. That's an option. And so you can keep doing this. You'll get whatever this is approximately. I don't have that answer for you, but you can do that very easily on your calculator. For this problem, you're going to change the log to an exponential equation. So we're going to go base to across the equal sign. So we're going to change, it's called the change of base form. So we're going to go 4 to the 3rd power is equal to x squared. In this case, we have 4 times 4 times 4, that's 64, is equal to x squared. And a lot of people like to just at this point square root both sides, and you're going to get x is equal to the square root of 4, which is 8. However, other people, there are choices here. You could say at this point where you say x squared equals 64, you could take like a half power. So you could take a half power of this and a half power of this. So that's a square root. And 64 to the 1/2 power is actually the same thing as saying x8 squared to the 1/2 power. 2's cancel, and then I get x equals 8. Lots of choices here. Just choose which way you like the best. For this problem, again, we're going to change the base. We have x to the 1/2 power. So we have x to the 1/2 power is equal to the square root of 30. Basically, this is x to the 1/2 power equals 30 to the 1/2 power. And if my bases, or excuse me, if my exponents are the same, my base is equal to each other. So I have x equals 30. Of course, there are other ways of doing this problem. Right in the beginning step, I could have just squared both sides. And in doing that, the 2 over 1, these cancel. This is you square a square root. The reason being is because you're squaring a 1/2 power. They cancel and you end up getting 30 anyways. For this problem, we are going to remove the variable from the exponent and pull it out front. So in doing that, we have 3t. Now I have to decide here if I want to log both sides or if I want to take the natural log. And I choose to take the natural log because the natural log and e are inverses of each other. So when I pull the 3t out, that's the same thing as saying ln of e is equal to ln of 8, but ln of e is actually 1. And 1 times 3t is just 3t is equal to ln of 8. T is equal to ln of 8 divided by 3. And ln of 8 divided by 3 is about 0.69. So if you didn't have a calculator, this right here would actually be your answer. If you did have a calculator, this would be your answer right here, 0.69. For this problem, we're going to go base to across the equal sign again. So we're going to go 5 to the 1 power is equal to 5x minus 6. We're going to add 6 to both sides. We're going to get 5x is equal to 11, and x is equal to 11 fifths. Okay. For this problem, we are going to solve this problem. It is in base 10, but before I solve this problem, I need to combine these two parts of the equation. So we're going to simplify a little bit. So in log properties, the log property of addition basically means this adding means multiply. So we keep the log base 10, but it's going to be x times x minus 15 is equal to 2. And then we're going to go base, which happens to be 10. Even though we don't see that, we know it's there. So we're going to go base to across the equal sign. So we're going to go 10 to the second power equals x times x minus 15. So we have 100 is equal to x squared minus 15x. In this case, I do notice it's quadratic, which means I do need to set it equal to 0. So I have x squared minus 15x minus 100. Let's factor. So we're going to get x minus 20 and x plus 5. In doing this, we split this up. We get x equals negative 5. X plus 5 equals 0, so x equals negative 5. X minus 20 equals 0, so we x equals 20. For this problem, you only have one answer. And the reason is when you plug in both of these solutions, you do get a negative, see this value right here, negative 5. You do get a negative argument. So I do want to caution you though, because people will make the mistake of plugging in this negative 5 into this equation that you've already simplified. And if you did that, you'd notice that that would be positive, but you actually need to plug it into the original equation, which basically means log base 10 of negative 5, and that's not going to work. Okay, so be very careful of that. The way I wrote this is x is equal to solution set of 20. Negative 5 was an answer, so you do show that out there, but we have a name for that. Basically shows that we have an answer, but it doesn't work when you plug it in and you check your answers. It is called an extraneous solution. For this problem, this problem actually needs to be done in 2 parts. The first thing we're going to do, this is my argument. This whole thing is my argument right here. So we're going to go base to across the equal sign. So we're going to say 5 to the second power equals log base 7 of x minus 2. So we have 25 is equal to log base 7 of x minus 2. Now, again, you have log base 7. We need to use the change of base formula, which again goes base to across the equal sign. So 7 to the 25th power is equal to x minus 2. So x is equal to 7 to the 25th power plus 2, whatever that is. That's what x is. For this problem, this is a really great problem. No, we're not going to get the same bases out of these two, and I am going to have to log. And when I do that, I actually have to log both sides. And so I'm going to get x plus 1 log 2 is equal to parentheses 2x minus 1 log 3. Well, in doing this problem, I am going to divide by log of 2 on both sides. So I am going to get x plus 1 divided by 2x minus 1 is equal to log of 3 divided by log of 2. For this problem, let me see if I have a number for that. I don't have a number for that. You are going to need to use a calculator in order to simplify that. And let's see if I have a calculator available. In doing that, I'm going to say, let's see, classes real quick. Hold on one second. We're going to say log of 3. So we're going to go log okay, calculator. So log of 3, and I'm going to divide that by log of 2. Now, I know you probably know the approximations of this, and you can use those, then that's fine. And log of 2 for this, and I end up getting, I don't get that. Let's see. 1.58 is what I got. And if that's the case, then I'm going to get x plus 1 divided by 2x minus 1 is equal to 1.58. And that's over 1. I'm going to cross multiply. I'm going to get x plus 1 is equal to 1.58 times 2x minus 1. I am going to distribute. So I have x plus 1 equals 1.58 times 2. And on these problems, here's the thing. If you estimate and you cut off your numbers, like here we cut off this approximation, what's happening with this is that the closer you close off your decimals, the less accurate your number is going to be. So if you had a calculator and you could plug all of this in, it'd be a lot more, your answer would be a lot more accurate. Because ultimately, once we do get x, we do want to plug it back in to see if we have the right answer. Is 2 to the whatever we got for x plus 1 equals to 3 to the 2 times whatever we got for x minus 1. Anyway, so multiplying, we have 16, carry the 1, 10, 11, carry the 1, 2 times 1 is 2 plus 1 is 3. So we end up getting 3.16. X minus 1.58. So we're going to subtract x. So I get 2.16x is equal to, I'm going to add 1.58 to get 2.58. And now I just basically have to divide 2.58 divided by 2.16. So let's see what we get here. 2.58 divided by 2.16, and I get 1.19. So x is about 1.19. And again, what I would do is I would take this number and put it back on the top just to make sure and verify that that I actually got the right answer for this. Okay. For the next problem, to find the inverse of y equals 2x plus 5, the steps for finding the inverse are starting with, you have y equals 2x plus 5. You switch your x and your y. So in order to switch my x and y, I'm going to have x is equal to 2y plus 5, and then I'm going to solve for y. So those are my steps. So move the 5 over. Now I have 2y is equal to x minus 5, divide by 2. So now I have y inverse equals x minus 5 divided by 2. So you had to find the inverse. You could also graph this. This is kind of a cool thing to graph because 2x plus 5 starts up 3, 4, 5, and then goes up 2 over 1. So this line actually does this kind of thing. And then, oh, I have a line. I can make a line. Let's see if I could do that. Okay, nope. Okay. And if I were to graph my inverse, that's, let's see, that is x over 2, or 1/2 x, minus 5 halves, right, is equal to the inverse. So in plotting that, that's negative 2.5. So it's about here, up 1 over 2, and this does this, and that goes that way. And what ends up happening, if you remember, an inverse flips across your, reflects across your y equals x axis. So if this is y equals x, you'll see how the inverses reflect across the y equals x axis. I think that's kind of neat. Okay, so for this problem right here, ln of the quantity x plus 1 equals 2. So for this problem, I'm going to replace ln with log base e. And now I have of x plus 1 equals 2. So I have e squared. Now remember, e is approximately 2.718. So, I mean, it's just a number, but we're just going to leave it in this form. So e squared base to across the equal sign is equal to x plus 1. So x is equal to whatever e squared is minus 1. And so that would be your answer. So I think I have an approximation for that. 6.38. Okay. For the next problem, for this problem, this was a good problem because what I can do with this is I can get the same bases. So I'm going to replace 4. You can't leave them as 4s, but you can replace 4 with 2 squared. So this is 2 squared. Don't forget the 2x plus 3 that's already up there. 32 can be replaced with 2 to the 5th power to the 5x minus 1. My bases are the same, so I can set my exponents equal to each other. So I can say 2 times 2x plus 3 is equal to 5 times 5x minus 1. So I have 4x plus 6 equals 25x minus 5. Subtract 4x, I get 21x. Add 5 equals 11. So I get x equals 11 divided by 21. Okay. For this problem, we have e to the 3x minus 5 equals 5. Again, I'm going to pull this out to the front. In the act of doing that, we get 3x minus 5 as a quantity. ln of e equals ln of 5. I am going to remind you that ln of e is 1. We have 3x minus 5 equals ln of 5. 3x is equal to ln of 5 plus 5. Do not combine those. And then you have x is equal to ln of 5 plus 5, all divided by 3. And let's see, I do have an approximation for you, and that's going to be 2.203. For this problem, I am going to solve for x, but first I need to combine these two terms. We have log base 5, add means multiplication, of x plus 6 times x plus 2 equals 1. Change of base form, we're going to go base to a cross equal sign. So we have 5 to the 1 power is equal to this value. So we have x plus 6 times x plus 2. We have 5 equals to x squared plus 2x plus 6x, which makes plus 8x. plus 2 times 6, which is 12, subtract 5, 0 equals x squared plus 8x plus 7. That's just going to factor pretty easily. I get x plus 7, and I get, what do I get? X plus 7 and x plus 1. And when I split these up, I get x plus 1 equals 0, x equals negative 1. I get x plus 7 equals 0, so x equals negative 7. Uh-oh, we have 2 negative answers. Let's go back to the original equation and plug them in. So negative 7 plus 6 is negative 1. Okay, negative 7's out. Negative 1 plus 6 is 5. That's positive. That will work. Negative 1 plus 2 is 1. Also positive. So my solution is going to be x equals negative 1 in a solution set with negative 7 outside to show that it is an extraneous solution. For this problem, we're going to move the negative 4 over. We're going to get 3 to the 2x plus 1 is equal to 8 plus 4, which is 12. Can't get the bases together, so we're going to pull this out. We're going to get 2x plus 1 log of 3 equals log of 12. 2x plus 1 equals log of 12 divided by log of 3. I'm going to subtract 1. Again, calculators are good. If you have a calculator, you can use that. You cannot, though, you may not divide your logs, and you may not divide 12 divided by 3. You cannot do that. Let's see. We're going to subtract 1. So we're going to get 2x is equal to this quantity, log 12 divided by log 3 minus 1. And then, of course, we're just going to divide by 2. And in dividing by 2 on both sides, my final answer is this equation right here. Whatever that equals, you can find that, figure that out on your calculator. I have a couple more problems here that I have done, but in these problems, they're already done. So you can look at those and see if there's anything that you may have questions on, and let me know, email me or let me know what those questions are. So I hope that helped. Here's another page for equations. Practice, practice, practice. Okay, so that was the end of our last minute Lucy review. So I hope that helped you, and thanks for watching. All right, bye.